We'll start. These are not the same weeks that you had. This is for some other. No, yes, these are the same lectures that you had. So you have learned. This is the summary. So you have learned the difference between vector and scalars. Am I right? We'll need to learn about vectors in this subject because we are working with forces and moments. Both are vectors. So the thing is, when you are adding, subtracting, multiplying, dividing vectors, you can't do it like scalars because there is a direction involved in vectors. So that's first week you learned about the vector diagrams and method of components, how to solve, how to find the resultant force or resultant moment, drawing the vector diagram, and also we are going to do questions. Okay, I'm just summarizing the things that you have done, and method of components. So you have some questions in this area in the final exam, and then you discuss about the moment of a force. Moment of a force is like about a point or about an axis. We'll do again a question. So you can consider Varigun theorem for that. That means you can, when moment is equals to force times the perpendicular distance. Am I right? So when you consider the perpendicular distance, sometimes you can't easily find the perpendicular distance. In that way, if you can't find the perpendicular distance for a force, you can consider the components of the force. So for example, for this force, if you want to find the moment about this point, if you can't find this one easily, you can find the components and you can consider the resultant moment from the two components. So that we call the Varigun theory. Again, we are going to do some questions, and we will discuss about the distributed load. And in your syllabus, you have only two kind of distributed loads: uniformly distributed loads and the triangularly distributed load. When you have distributed loads, you know how to make it to a single load. Am I right? So we are going to do some questions on that as well. And also couple moment, when there are two forces acting in opposite direction, same magnitude, but they are not, when you extend the line of action of the force, they never meet. They are parallel to each other. If you have two forces applied into opposite directions, same magnitude, and they are parallel to each other, then there is a couple moment. So couple moment, when you have a couple moment, the moment created by the force, couple moment, is equals to the perpendicular distance times the force. It doesn't depend on where you are taking the moment about. So moment about any point for a couple moment is just F times D. D is the perpendicular distance between the two forces. And when forces are in equilibrium, you know how to apply equilibrium conditions. So you have some questions in this section as well. Okay, and trusses. So up to here, I think you have, as I can remember, up to this week, up to here, you have 3 questions. Okay, in your final exam. We will do some questions. And trusses, do you know what are trusses? Yes, trusses are like this. So you can see trusses where? Roof trusses, and also you have bridges, and in the trusses, all the forces are, we assume, okay, in your syllabus you have forces acting only at the joints, no forces acting on the member in between the joints. So there are 2 force members, and you have we do truss analysis to find out the truss member forces, direction, also tension and compression, and also there are 2 methods to do this, method of section and method of joint. So you have 2 questions from this one as well in your final exam. We'll do some examples. And axial force, shear force, bending moment diagram for beams. If you consider beam, trusses are long thin members. When you consider beams are like this. So internal forces inside the beam. To find the internal forces in a beam, we draw bending moment, shear force, and axial force diagram. So you have 2 questions from this one as well. Okay, and 3 dimension, you have again 2 questions, and 3 dimension we recently did. I hope you remember. And we are anyway doing some questions. So friction, you don't have any questions. Friction is an easy topic, but however, you don't have any questions in that. Do you guys have any question regarding this? So it's 1, 2, 3, 4, 5, 6. Oh yeah, 9 questions, right? I said 9 questions. Yes, you have 9 questions in your final exam. But they are easy. They are long because you have all the steps given in the paper. However, they are very easy questions. Are we good? Can I move to the questions and see whether you understand things? Okay, so I'll move on to the next slide. Okay, week 1. Okay. So here I want to know whether you know method of components. So we need to find the resultant force using the method of components. Okay, there are 2 methods to find resultant force. One is method of component, other one is method of graphical method, where you draw them head to tail. Okay, I'm going to explain both the methods here. Okay, all right. Now, how do we do the method of components? Can I give you a few minutes for you to try, and then I will do. Okay, so here in the method of component, what you need to do is you need to find the components of your all the forces. So what are the forces we have? We have this 250. Am I right? Then you have a 400 Newton force. Am I right? And then you have a 300 Newton force. So I want you to find the components of these ones with the which direction is x positive? X positive in this way. If a component is in the opposite direction, it is a negative component, and the y is upward positive. Okay, so I'll give you a few minutes. So can you please find the components, please? So what is the component of 300? Y is what? Y is 0 and x is 300. How about the 400, this one? You're going to divide that into these 2 directions. Am I right? One is cos, the other one is sine. Which one is cos? X. So this word, this direction, you know the angle. Knowing angle, direction in the knowing angle is cos. So 400 cos 30, and positive because it is towards the right. And the other one is 400 sine 30. Again, it is positive. Am I right? How do we do this one? 250. So it's like this. 250, and they have given you this. This is 4, this is 3, this is 5. Okay, now how do you do this? If you consider this direction, you have 4. So this one will be 254 by 5. And if you consider the vertical direction, you have the 3 here. So that's 250 times 3 over 5. Am I right? Okay, so this one will be x is a negative, right? 254 over 5, and this one is positive, 253 over 5. Any question up to here? Okay, now can you find the resultant, the components of the resultant? So you add all the x's together and all the y's together, and you can have positive or negative numbers. So can you please find them? What do you get for the x? 446. How about the y? 350. Okay, do you all get this? Are we done with the question or not? We haven't finished yet. We have only found the resultant force x component and the y component. Am I right? Now we are going to find the resultant force. So how do you use these 2 components to find the resultant? How do we use these two to find the resultant? So x positive, am I right? So x direction you have 446 positive newtons, and then you draw them, you use the vector diagram method now. So in the vector diagram method, to find the resultant, you draw the components from start to end. So you are starting from here, you are going 446 along the x direction, then you have 350 again positive, so you go up, am I right? So start to end will give you the resultant. Am I right? So start to end, that will be this. So how do you find this? If you find the magnitude, that will give you the magnitude. The length of this line gives you the magnitude, and this angle gives you the direction of the resultant force. So how can we find the magnitude? You can use the Pythagoras theorem. Am I right? So this one, if I say R is equals to what? 446 squared plus 350 squared, square root of this, and in newtons. So can you find me that, please? What's that? 567 Newton. How did you find the angle as well? How do you find the angle? You can write the tan theta. Tan theta is opposite over the adjacent, and theta is 38 degrees. So how do you write this in a sentence? So your resultant is 567 newtons. You can do it in two ways. One is from where to where, using the north, south, west. So this is from
north, south.
North, this is south, and this is what?
East.
West. So this is from east to north, 38 degrees. So you can write it as this. And also other way is from the positive x direction in the counterclockwise direction, 38 degrees. Am I right? If you consider the x-axis, from the positive x-axis in the counterclockwise direction, 38 degrees. So you should know how to write the direction. So are we good? Okay, how do we find the resultant? Not this one, I will. Okay, so. Okay, I want you to do the graphical method as well to find the resultant, not for this question actually. Have you finished, or can I delete this part? Okay, so I will give you just two, okay? So don't consider the 300 force. Can you find the resultant of two vectors here? Ignore the third one, because graphical method is easy only with two vectors actually. The third one we'll ignore for the time being. You know how to do this in component method. So you have two vectors. I want you to find the resultant of these two vectors, not using the component method. You need to use the graphical method. Do you remember? You draw head to tail, and you can use cosine rule or the sine rule. Have you done that? Okay, can you draw the vector diagram, please? How do you draw the vector diagram? You can start either with the 400 or 250. Okay, so if you start with the 400, you start at a point. So this is your start. And 30 degrees, you are going 400. Am I right? And then where you are going? Now you have to go this direction. How long? 250. What is that direction? It can be 4, 3 and 5. So it's like that, isn't it? Am I right? Now this is my end. So resultant is always given by start to end, isn't it? So if you draw start to end a line, so this will be your resultant. Agree or not? Okay, if I want to find this theta, what is the theta? This tan theta is 3 over 4. So I can find this theta if I want to. Am I right? Because this theta we can find if we want to. So that is, can you find me the theta, please? Do you have any question? Are you okay with drawing 400? It is just making a 30 degrees from the horizontal axis. And this one is making, so you are here. Then you draw the other one from this point because it is always you're connecting vectors together. And what is the theta here? 31 degrees. So this is 31 degrees. So from the horizontal axis it is 31 going 250. So this is the end. Start to end will give you the resultant. So now we know this total angle is 61 degrees. Agree or not? Okay, now you can use the cosine rule. What the cosine rule says, cosine rule and the sine rule. If you have A, B, C as your angles, and if you have lengths as A, simple B and simple C, what the cosine rule says, if you know, cosine rule can be used if you know two lengths and the angle between the two lengths. If you know these three, you can write the C. C is what? A squared plus B squared minus what? 2AB cos C. Am I right? Is this right or wrong? Have you done this or not? Okay, so can you use this? Can we use this and find this R? Do we know the two lengths and the angle between two lengths? Yes, so we can write R is what? 400 squared plus 200 squared, 250 squared minus 2 times 400 times 250 times cos 61. Agree? And this is, sorry, C squared and this is R squared. So you need to find the R. You have to take the square root of it. And can you find me the R now? So this method we call the graphical method, vector diagram method. Okay. So if you want to find the resultant using the vector diagram method, you can use this. But this is easy when you have only two vectors, because otherwise still the rule is valid, but you don't end up with a triangle. You will end up with a four sides, isn't it? So component method is easy when you have many forces together, but vector diagram method is easy when you have just two vectors. Can you find me R, please? 354 newtons. Okay. So the resultant, magnitude of the resultant we found. How do we find the angle of the resultant? We use the sine rule to do that, or else you can use cosine as well, but sine is easy. What the sine rule says? Sine rule, do you remember? Sine A, yes, or A over sine A over A is equals to sine B over B is equals to sine C over C. Or else you can change the up and the down. Okay, A over sine A, also you can write it like that. Okay, now how do we find this angle? Just I'm saying this alpha. So how do you write the sine alpha now? Sine alpha divided by what? Sine alpha divided by 250 is equals to sine 61 divided by 354, which is R. So can we find the alpha?
$38.
38 degrees. Okay, so are we all good up to here? Any question? We'll do another question. If you came late, we'll do another one. Okay, are we good? Now how do we write this answer? So it is 38 here. Am I right? From the x-axis it will be 68 degrees. Do you agree? So your resultant force is 354 newtons, making a 68 angle from the positive x-axis in the counterclockwise direction. Am I right? So you can write it in words. Are we good? Any question? Okay, there is another thing. If you have three forces here, for example, I'll say, okay, Can I erase this one? Okay, so I'm going to say this. So I'm going to give you another question. I want you to try this, okay, from the same thing. So we have okay, so we have this. I'm saying that we don't know this 300, okay? So we don't know this 300. I'm just saying this is F. I'm telling with the three forces, this is in equilibrium. I want you to find the F. If this is in equilibrium, what should be the F? Use the vector diagram method and tell me how to do this one. Let me see. Let's say no. I'll give you an F in this way. It's easy. Okay, so I have yes, F. This is your F. Find the F. If this one is in equilibrium, this point, okay? Don't worry about these supports and all that. I'm saying there are three forces acting on a point, and the three forces are in equilibrium. This one is in equilibrium, so find the F. How do we draw the vector diagram now? And find the F. How do we? You can do it in component method, but component method you are already okay with that. So I want you to do the vector diagram method. How do you draw this? So when you draw the three vectors, what you should get? If it is in equilibrium means what? What is your resultant in equilibrium? If something is in equilibrium, what is the resultant force? Resultant should be zero, isn't it? If there is a resultant force, we can't say it is in equilibrium now, so resultant force is zero. So when you draw the vector diagram, resultant force is given by start to end. Am I right? Resultant is always given by start to the end. If the resultant is zero, your start and end are equal. Agree? So it should make a closed polygon. Do you agree with that? So when you draw the vector diagram, so you are drawing a 30 degrees, you have 400. And again in 31 degrees, we already found it, you have 250. And when you draw the downward one here, your start and end should be at the same point. So this is your F. Agree or not? Now you have a triangle. You can use the cosine rule and sine rule and find the F. F is anyway given in the downward direction, but if it is in a other direction, you can find the angle as well. Agree? Are we good? So how do you find the F? F is equals to what? 400 squared plus 250 squared plus 2 times, sorry, minus 2 times 400 times 250 cos 61. Square root of this will give you F. Am I right? In this case, F angle is given to you, but if the angle is not given to you, you can again find the angle as well using the sine rule. Are we good? So that covers your first 2 weeks, I guess. Component method and the vector diagram method. Are we good? Any question? So you have 2 questions in this section, okay? 3 questions with the support reactions. We haven't done the support reactions yet. We'll do that. With the support reactions, we have 3 questions actually. Can I move on, or do you need time? Move on. Okay, I want to give you some more questions. So let's come back to those questions. So that, what do you know about the moment of a force? Can I give you a few minutes for you to find the moment of this force? So this is a new question, okay? If you didn't understand the first part, forget about it and try this one, because at least you need to do this one. You don't need the previous knowledge to do this. What do we mean by a moment of a force? Moment is equals to force times the perpendicular distance. Am I right? So about a point. So here we are taking the moment about A. Am I right? So from the A to the force, you need to draw a perpendicular line. Perpendicular means it is making a 90 degree here. Am I right? So how do you find this perpendicular distance? So this is 2.5 and this is 38. So that will be, if you write the sine 38, that is equals to opposite, which is this x divided by 2.5. So x is equals to 2.5 sine 38. Am I right? So you can write this as 446 times 2.5 sine 38. Agree or not? Now tell me how to find the direction. Is it, when you consider about the A, this force is going in the clockwise direction or the counterclockwise direction? How do you know? So when you consider here, this is going this way, right? So from this point, if you draw the arrow is this direction, so you go like this. So this is making a clockwise moment. So you need to write the direction as well, otherwise you lose marks. So the moment is whatever you get when you put this in the calculator times Newton meters. Am I right? Moment is measured in Newton meters and the direction is clockwise. Are we good? Okay. What's that? 686 Newton meters in the clockwise direction. That's good. Okay. Let's see. Okay. So what this question says. Now this is again a moment question. But it has the other things as well. A beam that is secured on a wall at A is subjected to 800. Okay, all the calculate the resultant moment of the full load force about the point A. Okay, now we need to find the resultant moment about A. How many forces are here? So you are going to find the moment about A. So you have to find the moment of all the forces. Okay. So moment is the force times the perpendicular distance. Now tell me, what is the moment made by the 1000? 0? Who is telling 0? Why it is 0? Yes, perpendicular distance is 0. So when a force is going through the point where we are taking the moment, that moment is 0. Okay, so when you extend the line of action of the force, so this 1000 is going through A, so the moment is 0. Agree? Okay, now how about the next one? Tell me, this one 800. Is it making a moment? It's not going through the point. So it is 800 times the perpendicular distance. So what is the perpendicular distance? From A to the line of action of the force. So you extend the line of action of the force and you draw a perpendicular line 90 degrees. That distance is 0.2. Agree? Am I right? Is it making a clockwise or how do you know? So from this point, this is pushing down. So if you draw a circle around the A, it is in the clockwise direction. Am I right? So clockwise moments we consider as negative, counterclockwise positive. That's how the sign convention for moments. So this is a negative moment. So we found the moment created by 800 about A. Any question? Can you find the other moments, please? Okay, how about this 1200 Newton force? Okay, the force is 1200. What is the perpendicular distance? You extend the line of action of the force and you draw a perpendicular line to this one. 0.5, this is 0.45, yes. So that will be 0.45. And is it making a clockwise moment or a counterclockwise moment? Going this way, right? So that will be a positive moment. Agree? Okay. Now the 720 times 0.7, and it is going, so it is negative. Am I right? So we consider all the forces. There are 4 forces, and we consider the moment about A. And what is the resultant moment about A now? You just put this in the calculator and you find it. What you get? What's that? Is this right? Okay, now I want you to do the second part, B. Can you do the B, please? I'll give you time. I want you to do the B by yourself. So you have 4 forces. Find the moment about B now, okay? I'll give you time. Is 720? Okay, so we are going to take the moment about B. So this 700, is it making a moment or not? No, why? It is going through the point, so it is 0. How about this 1200? 1200 times 0.25. Which direction it is? It is clockwise, right? How do you know the clockwise? You draw a perpendicular line to this one, and it is from here, the arrow is going this way. So if you draw a circle, it is going like this. So it is clockwise. That means it is a negative moment. Okay, how about this 800? 800 times 0.5. Am I right? This distance between these two is 0.5. So it is making a counterclockwise moment, positive. Then you have another negative moment, 1000 times 0.45, 0.7. Yes. When you add all this together, what is your moment? 1080. Positive. Positive means what? Counterclockwise. Previous one was negative. That means the resultant moment about A was clockwise. Are we good? This is minus. In the yes, I think these two are higher than, yeah. So it should be negative, yes. So it is a clockwise moment. Moment, you have to pay attention to the direction. I have seen students, they don't know how to find the direction. So the easier way is you draw a perpendicular line and you draw a circle. Arrow is up, so draw a circle this way. Arrow is up. Okay, so this one, arrow is down, draw a circle going this way. This one, arrow is up, going this way. Make sense? You draw the circle about B because you're taking the moment about B. Are we good? Any question? No questions? Okay, that's good. Okay, yeah. So here, Varigan theorem. So if you want to find the moment of this force about O, what is the method that how do we find it? You can extend the line of action of the force. Am I right? And draw a perpendicular line from O, and you need to find this distance. Am I right? But here, when you have forces, the slanted forces like this, it is not easy to find the perpendicular distance. Am I right? So if the perpendicular, but there is nothing wrong if you can find this by any way, you still can use 400 times d is your moment. And also it is in which direction? It is in this direction. So it is in the clockwise direction. You can find it if you find the d. But if it is hard for you to find the d, what you can do is you can use the Verigans method. What the Verigans method say? You divide this force into two components perpendicular to each other. So when you divide this into two components, what is the y component? 400. Why can this one I'm asking? 400 cos 30. How do you remember this? Towards the known side. So if you know 30 side is cos, always 30 side, known side is cos. Unknown, this is unknown. Unknown side is always sine. You can go with the basics. If you write you can do like, you can draw the triangle and see it, but you still get this. So easy way to remember it is known angle side is always cos, unknown angle side is sine. Make sense? Okay, now you don't have this 400. Instead of the 400, you have two components. Now can you find the moment of this one is, so if you add the two moments together by the components, you will find the moment about or for this 400. Okay, can I give you a few minutes to find this? Okay, so we'll take one at a time. So if I take this y component, you extend the line of action of the force and you draw a perpendicular line. That distance is 0.4. Agree? So that will be 400 cos 30 times 0.4 and making a clockwise or counterclockwise? Clockwise. So this is negative. Agree? And the next one, extend the line of action of the force and draw a perpendicular line, and that distance is 0.2. So that will be 400 sine 30 times 0.2, making a what direction? Counterclockwise, going this way. So that will be a positive moment. So when you add these two together, you will get the moment of the 400. This previously given 400 about O. So what do you get? Negative 98 something. Okay. Negative means the resultant is in the clockwise direction. Newton meters. Are we good? Okay, again, can you find the moment of the force about A? Okay, so you need to find the moment of these forces about A. How come different people get different answers?
Like the 150 Newton force, the both forces, if we separate them, then they are going to give us the clockwise direction or the counterclockwise direction. Yeah, it's all clockwise. Yeah.
Okay, this is 150 sine or cos? Sine. Why? Unknown side. So 150 cos 60. What can you say about this one? It is going through A. So this is 0. Okay. And these two are making moments. Both are in the clockwise direction. So it's a negative 150 cos 60 times 5, negative 350 times 2 Newton meters. Okay. That's good. Are we good with the moments? That's good. Now we'll do the couple moments. Okay. How do we recognize couple? It's when you have moments, question to find moments, it is important to find couple moments, because if you know couple moments, you can easily you already know the moment. So how do we find, what are the requirements for having a couple moment? You need to have two forces acting in opposite direction, same magnitude, but separated, parallel to each other. They can't intersect. They have to be in parallel, opposite direction, same magnitude. So do we have couples here? Which ones? Okay, 150. So what is the magnitude of this couple moment? 150 times the distance between the forces, perpendicular distance between the forces, which is 2, and it is making what direction? Take your hands and like it is in the counterclockwise. It's like you are holding and turning in the steering, like a steering wheel. So it's going in the counterclockwise direction. So this is positive. Agree? How about these two? They are also couple moments. Why? Same magnitude, opposite directions, and they are separated with 0.2. So that will be 350 times 0.2, and it is going in which direction again? Clockwise. So it is a negative moment. How about this 200 and 100 again? Couple moment, because they are same magnitude, opposite directions, separated by 5 meters. So 100 times 5, and it is going in the clockwise direction. So it is negative as well. So you add these three together, and then you get the resultant force, resultant moment. So resultant moment is what when you add all these together? Minus 900 Newton meters, 900, and negative sign says clockwise direction. So if I ask the moment of all these 6 forces about A, what is the resultant moment of the 6 forces about A? What is this? If you find all the 6 moments and add them together and find the moment about A, what it should be? It is 900. If I ask you to find the moment about this point B, it's still negative 900. If I ask somewhere here, it is still negative 900. So that's the easiness of the couple moment. Regardless of about which point you are taking the moment, your couple moment will remain the same. It doesn't depend on the moment, which point you are taking the moment about. Make sense or not? Is it clear or not? Okay. So even if I ask you to find the moment about A, B, C, or whatever the point, if you only have the couple moments, the moment created by a couple is the same, so that won't change. Make sense? Are we good? Okay. Trust me, can you find the moment of all the 6 forces about A and check whether you get 900? Negative 900. One by one, you still should get the negative 900, but check whether you get it. Doesn't matter A or B or whatever the point, if you have couple moment, it should be the same, which is negative 900. Okay, here, this 100 is not making any moment about A because it's going through the point. Am I right? This 300 again is going through the point, so this is not making a moment as well. And this 100 and 150 are in the same line, so you can consider it as a net force of 50 upward. Agree? And now you only have 3 forces to find. So 350, 50 and 150. Okay, you are taking the moment about A. 150 will be 3 times 150, making a clockwise moment. And this 50 times 5, making a counterclockwise moment. And this one, if you consider, it is making a clockwise moment. Am I right? And that is a negative 350 times 0.2. And when you add all this together, you should get 900 Newton meters negative. Do you get it? Is that right? Let me 50. Do you get 900? It's not 900, right?
It's not 900.
Yes, yes. That means your previous one was wrong. Your previous 900 should be wrong, boys. You need to double check.
It is 230. It's 230?
This one, what do you get?
230.
Negative 230. I don't say it's 900 as well. Can you find
900.
the previous one also? It should be wrong. What do you get here?
It's 230 positive.
Yeah, 50 times, okay.
It should be 230 positive.
Do you all get 230 positive? Put the numbers in the calculator and find it.
Oh yes, actually no.
250? 230.
Minus 770.
How come you get so many different answers? Can you confirm what you get? 3 times 150. Let me do the calculations.
Well, it's, yeah, I think it's 230. Yes, 2. No, it's not 230.
It's 320.
No, it's 230. It's actually 230.
It's actually-
Yeah, 230. 230, 230. 100%.
270, isn't it?
Yeah.
Negative 270?
Yeah, minus 270.
Yeah, what, negative 270.
Yeah.
Okay, I want you to do the couple moment part. How come you got 900 there? Can you find it again, please? 900. How do you do it? Find the couple moments now. Couple moments. So this 2 will be 100 times 5, and that is in the clockwise direction. And then this 2, 350 times 0.2, it is in the clockwise direction as well. And the other one is in the counterclockwise direction, positive 150 times 2. When you put these ones, you should get the same answer, which is negative 270. Do you get it, Tom?
230. So you see that one? That one is 70, so 70 plus that one should be 30. Will not be 70.
270, negative 270. Take the calculator, just press the numbers and see. Okay, so the last one, 900, is wrong. So do you see that when you consider the couple separately, or else if you take the moment about the point, you will still get the same answer, okay? When you have couple moments, you can easily do it in this way. Are we good? Okay, now you have forces and couple moment. You know, when you have a couple moment, regardless of where it is acting, you can still, like, you know, consider the moment created by the couple. Okay, I want you to find the total moment about A for this whole thing. Find the moment about A. You have 3 forces and a couple moment. What's that? This one. I will redraw this.
negative 30.
Okay, so this is what you have. Take the moment about A. What is the moment by 10? 10 times? 1, positive or negative? Negative. How about 6? Negative 6 times? 3. How about this 15? Okay. How about this 12? Negative? 12 times? Okay, so you don't have to consider the distance for the moment. Okay, it's already a moment, so you don't need to multiply that by a distance. Okay, so when you add all this together, what?
Minus 40. Oh, yeah, 40. Minus 40.
Okay. Okay, how do we you only have two types of distributed load. So how do you replace the distributed load by a single force? So this one, how do you replace it? So you will get this, okay, in your equation sheet you will get this. So when you have a triangularly distributed load from the tip, the resultant of this, you can replace this by a single force. The force is the area of the triangle. So you know this one it's given. I also can't see it. It is 15 kilonewtons per meter. 15 kilonewtons per meter. So this length is 15 and this is 9. So how do you find the area of this? Yeah. So half times 9 times 15 is your force. It is acting in 2 over 3 times L. L means 9. So you can replace this by a single force this way. Make sense? Are we good? So if it is a triangular, this 2 over, this is always from the tip, okay? So this is another place where students go wrong. You are not measuring this to 2/3 of the length from this end. It is always measuring from the tip of the triangle. Make sense? Okay. And the next, can you find this one, please? This is 7 and this is 5.5 and this is 3 and this is 8. So this one is always applied at the center and the area is just 3 times 7 here. This one is 5.5 times 5. Am I right? This is 5. Okay. Find me these two, please. No, I want you to find these two forces. So if you consider the beam, you have one force acting here which is 21 kilonewtons and one is 27.5 kilonewtons. And this one is acting at 1.5 meters and this one is 2.5 plus 3, 5.5. Am I right? Does that make sense? Okay, now if I ask you to convert this to a single force, so I want you to find this single force and where it is acting on X and this. So you are now converting this to a single force. Convert it to a single force. How you do that? What's that? Yes, force magnitude is you are adding them together. So force is 21 plus 27.5. So what is X? How do you find the X?
X, you find it.
You need to find it. How do you find it?
Using the moment.
You using the moment. So can you find the x?
Moment equals zero.
No, moment of one diagram is equal to the moment of the other one, because both the diagrams are the same. If you consider the moment of this one, if you consider this, it will be x times f. Am I right? The other moment is what? 21 times 1.5 plus 27.5 times 5.5. These two are equal because it is the same loading system. And the only unknown is the x, and you can find the x. Make sense? Any question? Can I move to the next one? Okay. Now you need to find this, and I want the one force. Okay, you can make it to two forces, then you have to make it to one force. You see this or not? This is 10, and this is yes, this is 6, and this one is 3. Okay, I'll give you time. Okay, first we need to convert this to two forces. So how do we do it to two forces? So this will be 10 times 3 and acting at 1.5 meters. Am I right? And this one is half times 10 times 3. Am I right? So that will be 15 and acting on 2/3 of L. Okay, so L is this distance here, 2 meters from the tip. Okay, from here it is from the tip all the time. This 2/3 will be from the tip, so this will be your 2 meters. Make sense? And if you consider the length from here, that will be 4 meters. Now to convert it to a one force, then that will be 15 plus 30, which is 45, and this x distance you can find. How do you find it? X times 45 is equals to 30 times 1.5 plus 15 times 4. So you can find x. You all are in the same direction. So yeah, both all are clockwise, so you can put minus everywhere. The minus will cancel out. What is x? 2?
For example,
45 plus 60 divided by 45. Am I right? 2.3 meters. Is that right? Okay. All right. So I will give you a break, and we have another classroom. Come to that. That's the same. Today you don't have practicals because you have already finished the practicals. So we are going to continue with this one at the same class which you have normally, the tutorial. I can check and we'll let you know. See how to solve equilibrium questions, okay? So equilibrium questions we can do, there are two types of equilibrium questions. One is particle mode, where you have all the forces going through a single point. So if you look at this one, all these forces are going through a single point. So in these ones, equilibrium means, what do we mean by equilibrium?
Like these are the tutorial questions, or
I think maybe similar to tutorial questions, but not exactly the tutorial
like
questions.
we can get these questions at the Google.
I will email this to you, this PowerPoint to you guys.
The questions are coming to the exam. They are similar to these ones.
Similar to these and also the tutorial. These are also similar to tutorial, but not exactly the tutorial questions.
Yeah.
So your final exam questions are very similar to what you have done, this and the tutorial, yes. Okay, so equilibrium means net force is 0. So net force is 0 means force, if you add all the forces in the x direction, that is equals to 0. Sum of the forces in y direction also equals to 0. And the other thing is rotationally, a moment about any point also should be equals to 0. Am I right? Otherwise it can rotate. So these are the three equilibrium conditions that you are going to use. If something is in equilibrium, you can say that sum of the forces in x direction equals to 0. Some
Forces are going to be equal to 0, then it is a translation equilibrium, and if it is a movement is equal to 0, then it is a rotational equilibrium.
Yes, so when in our questions, actually we are dealing with static questions. So the F is equals to 0 means the object can move with a same velocity, acceleration is 0. But in our case, nothing is, we are dealing with static things. So they are stationary. So we can say they are not moving at all. But if there is a force, it should move. So in our case, everything is in equilibrium. So nothing is moving except the friction part. Friction, you don't have a question. So in our case, all three should be satisfied. Even the rotational, translational, all should be 0. Okay, and when you have particular mode, that means when all the forces are going through a single point, anyway the moment is 0, because when you consider the moment about that single point, moment is 0. So you don't need to apply that. You only consider the forces in x direction is equals to 0, forces in y direction is equals to 0. So you can have two methods to do this. One is considering the component method, and the other one is considering the vector diagram method. We are going to do all three. Okay, so so let's do the component method first. So they are asking us to find these two. Let's do the vector diagram method. So equilibrium means what? Your resultant is 0. So when you draw the vector diagram, the start should be equals to the end. There should not be gap between start and the end. I told you before as well. So when you draw this, you can start with any one. So if I say F2, this is my start point, and I have to go 100 this way, and then I have F3. Am I right? F3 going down. I don't know how much. I'm going to find it. And then I have F1. It should end at start. Why is that? Because start should equal to the end. Equilibrium means you don't have a gap between start and end. No resultant force. Start to end gap will give you the resultant. So equilibrium means no resultant. So this angle we have as 50, and this is 50 as well. Now you have a triangle. It's a right angle triangle, isn't it? Because this is 90. Am I right? So you can use Pythagoras or whatever, maybe sine, cos, tan, and you have to find this unknown two forces, F1 and, sorry, this is F1, F3 and F1. How do we find this? You can use cosine rule as well. You can use anything and you can find it. You can use sine rule, easy. How do you do this? This should be, if this is 50, this angle should be what? This one here. 40. So you know three angles. You can write the sine rule here. Sine rule says F1 over the opposite angle, which is sine 90, is equals to 100 divided by sine 40 is equals to F3 divided by sine 50, isn't it? When you consider these two, you can find F1. Am I right? If you consider these two, you can find F3. That's easy. Okay, can you find me F1 and F3, please? Did you understand what we did? Are you okay with this? So can you find F1 and F3, please? You do by yourself, okay? Now, don't look at this. Just start from the beginning and do by yourself and let me know what you get. 119 newtons. and F1. Let's see if everyone get the same answer. This is a really easy one. F1 is what? 155. Are we all good? So any equilibrium questions? Your start and end should be equal to 0 if you do the vector diagram method. Okay, you need to remember that because there should not be any resultant force.
Yeah, 155.
Okay, 155. And you don't need to find directions here because the directions are given to you. Okay. Are we good?
After it's 119.
Okay, yes, 119. Okay, I want you to do the same thing with the component method. So they are saying this is in equilibrium. So when you have particle mode equilibrium problems, that means particle mode means what? All the forces are going through single point. You don't have to consider the moment, you only need to consider the forces. So we solve this using the vector diagram method. Now we are going to do the component method. So if something is in equilibrium, your sum of the forces in the x direction should be equal to 0. Sum of the forces in the y direction should be equal to 0, right? So what are the components of the forces? So you have F1 force, F2 and F3. So what are the components of these? In the x direction, F2 is 100. And what is F1? F1, you have to find the components now. You have, yes. Cos is, which one is the cos? This one, right? So it is the x component, negative F1 cos 50, and the y component is positive F1 sin 50. And this is 0. How about the F2, F3? X is 0, this one is minus F3. Do you agree? Now if you add all these together, minus F1 cos 50 plus 100 should be equals to 0. Why? The system is in equilibrium. So you can find the F1, which is 100 divided by cos 50. If we have done it right, it is 155. It should be. Can you check please? Because we already did this with the vector diagram method. Is it 155? Close to something like that. Okay, now the next one. When you add all this together, again it should be equals to 0. So you can say F3 negative plus F1 sine 50 should be equals to 0. So you should have F3, which is F1 sine 50. So 155 sine 50. Do we get 190 or 19 or something? Get it? Okay, so we did the same question using both the method, vector diagram and also the component. Are you guys okay with that? Okay. Can I move to the next question? Okay, now where equilibrium conditions we can use to find support reactions. There are 3 types of supports in your supports. So tell me, when you have pin support, let's start with the roller support. So you have 3 supports. One is roller support, pin support, and the fixed support. So this is my beam, okay, part of the beam. Okay, so roller support is what? No, roller is it. Look at this one. Roller support. Roller or rocker. It let the beam to move in this direction. direction, it's only preventing going down, isn't it?
Yeah.
So there is a reaction only in the vertical direction for this one. So when you draw the free body diagram is you are only considering the beam or a part of the beam and replace forces. So this one, when you replace it, it just have one force. Make sense? Pin is like a pin. You keep two things and just pin it. So it can rotate, but it doesn't let moving in x direction or the y direction. So when you replace a pin support, you need to replace it with both forces. Make sense? And fixed support is not letting even to rotate. So fixed support is three unknowns. Make sense? So you have the Fy, Fx and also a moment. Okay, so this is how we replace. So these support reactions, we should know how to find it. We can
The fix is for, we have three.
yes, so the fixed support 3 unknowns, pin support 2 unknowns and roller support 1 unknown. Okay, so first thing is, when you have a beam like question like this, even for trusses, you first need to identify what supports you have. So here in this beam, what are the supports you have? Normally they give it in this one, but here you can just look at it and tell me what is this support at the A? Pin. So how can I replace the pin? Fy and Fx. How about B? Roller. So it just have, I say By. Maybe I say Ay and Ax, so that we know Ay and Ax. Okay. Now, so I'm going to delete this part. So this diagram we call the free body diagram. What we have done here, we have taken the supports out and replaced with them with forces. Okay, so if you have to draw the free body diagram of the beam, it should look like this. Make sense? Okay, so now I'll remove these ones. Now we apply the equilibrium conditions and we are going to find the three unknowns. Okay, so what are the equilibrium conditions? One is all the sum of the forces in x direction should be equals to 0. So when you consider all the forces in x direction, what are the forces in x direction? Ax, and we can divide this into two components. Am I right? So this one will be 2000. When you have like this, what did I tell you? Times. So we are finding the vertical component. Vertical direction, you have a 4 and you divided by the 5. Make sense? And this one here will be what? 2000 times. You have 3 in that direction. 3 divided by 5. Okay, and you have Ax plus this one also towards the right, that is equals to 2000. 3 over 5 is equals to 0. So you can find Ax. Am I right? Now if you consider all the forces in y direction, that also should be equals to 0. So what are the forces in the y direction? Ay plus 2000. No, which one is that? All the upward forces are plus, downward forces are minus. So you can say Ay plus By plus 2000. This one is 400, 1200, isn't it? And it's sorry, it's negative. Negative minus 1000 is equals to 0. So here we have two unknowns. We need to find one now. The other condition is what? All the forces in x direction should be equals to 0. All the forces in y direction should be equals to 0. Moment about any point should be equals to 0. You can take the moment about any point, but it is easier if we take the moment about A, because both of these forces won't come and we can find By. Do you agree with that? So when we take the moment about A, counterclockwise positive. So I'm taking the moment, these two are not there. So I have to take the moment of this force, which is equals to 1000, not 1200, that one. Oh, I did it wrong here. 1400, 4 times, this is 16, isn't it? This one, it should be 16. Am I right? This should be 16, isn't it? Because this is the horizontal part, not this one. This should be 6. This is the one we are talking about. So that one is 1600 what? Times 2 negative. Why? Clockwise. And then we have negative 1000 times 4. Am I right? Plus by times 4 is equals to 0. So we can find by. And when you find the by, you can substitute the by here and you can find ay as well. So we found all three unknowns. Make sense? Are we good? Can you find me why when I taking the moment I didn't consider this one here? Why I didn't consider this force? The horizontal component of the 2000. It's going through the point. In some situations, they ask you to consider the thickness of the beam. In that case, you need to think about it. But if they say ignore the thickness of the beam, and if it's not given, you can just consider it all like it's a very thin beam.
If the thickness is given, then we need to do it, yeah?
Yes, I'll show you when you want to do it. And can you find me AY, AX, AY and BY, please? Found it? Okay. Do you understand what I did? Okay. If everyone gets 1800 for BY, 1800 newtons. AY is 800. They can be positive or negative, okay, depending on, we assumed it's upward, but maybe like it can be downward. So AX is a negative anyway. How did you find AX? AX is 1200 negative. Do you get that?
AX is gonna be, I think, 0 because it's cutting the point.
No, you already found this. See? How come it is 0? 1200 negative.
AX is 1200.
Yes, negative, right?
Yeah, negative.
Yes. Okay. Are we good? Okay. Okay, now I'm going to show you where you need to consider the thickness of the beam. In some cases, if something like this. If you have the same beam, okay, I'm taking the same beam and I'm going to redraw the beam. If I say this is at the middle, it should clearly show you, otherwise you can't do it. So this is at the middle of the beam, okay. If I say this is 0.4 meters, okay, I'm just taking a number. In that case, this force is applied at the top. Can you ignore when you're taking the moment about this point? Can you ignore it? You can't. That force, line of action of that force is not going through A. Do you see that? So you have to consider the moment about this direction, which is 1200 times 0.2. Make sense? So there can be some questions like that. You can't ignore the thickness of the beam, and they will clearly show where these points are. A is at the middle and this is at the very top of the beam. So in that case, you need to still consider that the moment. Makes sense? If the force is line of action of the force is not going through the point which you are taking the moment, you need to consider the moment of that force.
If the thickness over there, then BY is going to be different, for sure.
Yes, your BY and also AY will be different, because AY is depending on the BY now. your moment is different, so that those two will be different. Okay, are we good?